Good afternoon, everybody, and welcome to our webinar on automating deployments for increased speed and agility. My name is Ross Beard. I'm here with Shadowsoft, and we're really excited to have you here today to talk about this very exciting topic. I want to introduce our speaker today, Mr. John Ray. John is a practice manager here at Shadowsoft, and he will be sharing his ideas on automating deployments, building CI/CD pipelines, and measuring the metrics that matter. A lot of the content that he's going to be talking about today is based on work he's done with customers over the last 12 months. Before I pass it off to him, we do want to hear as many questions that you have, but I do ask you use the chat pane to ask the question, and then once John has wrapped up his talk, we will do the Q&A at the end. On that note, I am going to hand it over to John Ray.
All right. Hello, everyone. This is John Ray, and as Ross said, I'm a practice manager here at Shadowsoft. My focus is on cloud solution architecture, so the design and implementation of solutions that are intended to be cloud native. In this particular case, cloud native can also mean on-prem, but your on-prem cloud. So think your VMware, your on-prem OpenShift implementation, something like that. And what I'm going to talk about today is some overall big picture industry things and industry best practices, quote unquote, that get thrown out at folks, and how those things can muddy the waters, so to speak, around your automation projects. We're going to talk a little bit about how to select tooling. We're going to talk about some metrics and why measuring these metrics are very important. We're going to present you with a miniature framework that Shadowsoft uses to help clients on their automation journey and make sure that there's no kind of holdups there. So let's get started. So I'm sure everyone has heard, and your boss has probably told you, we have to automate. People who are automating are doing all these amazing things. We have to catch up. And it's true in a lot of ways, because what we're seeing is that in the past, it used to be that the big fish eats the small fish. So you have your large company that would have more resources and money and manpower, and they would be able to snap up smaller companies and outperform just based on kind of this legacy machine that was rolling forward. But in today's society, where automation is becoming more and more frequent, what we see is not the big fish eating the small fish anymore, it's the fast fish eating the slow fish. And so because of that, we're led into this place where DevOps and automation are presented as a panacea of all of your possible worries, and if you would just automate this one thing, you would have kind of the numbers that you see here, right? 24 times faster recovery and 200 times more frequent deployments. But not everybody's trying to deploy things 200 times more frequently, right? Or those numbers often can scare people and say, well, wait a minute, what does it take to really get to these types of numbers? And so the industry throws a lot of best practices at you. And one of the things they throw at you is that, well, you should just automate everything. And that seems great. It seems like a really solid way to go about things, but it's actually the most horrible way you can possibly start an automation project. So Gartner says that 75% of DevOps initiatives will just straight fail to meet any expectations in the business, and that most of the time this is due to organizational change, or the lack of organizational change. So if you look at classical change management, what you see is that there are 5 or so things that are leading indicators of whether or not you're going to be successful in any initiative. And so these things have to all be in place, even for something as simple as your automation project. If you don't have the necessary resources to accomplish what people want, right, then your expectations are going to be out of line, and you won't achieve the goal that you think that you need to achieve. If you don't have a driving vision for what you're trying to accomplish and what that end state is going to be, then it can just kind of get confusing and people can kind of get frustrated. And so when starting your automation project, there's this kind of conundrum where you go, oh, we should automate everything. But then you realize that you can't. You can't actually automate everything. You run into situations all the time where you have a legacy testing procedure that requires a person to actually do a thing, right? And so you can't necessarily automate this person doing a thing. There are tools that are trying to help solve that problem, but they're not fully matured yet. And so when you look at what you're trying to automate, you realize very quickly that you can only automate the things that you can sit down and fully describe on paper. It's not good enough to write down a list of things and then say, okay, thing number 5 is go tap Bob on the shoulder and ask him to do his thing. If you can't articulate what Bob is actually doing and do it in a way that can be described in code, then you're going to have a really hard time automating that. The other thing is that you can't really automate everything all at once. So a lot of folks will try to say, I'm going to automate my entire web application stack. And it takes forever to get that done and get it done correctly. And what ends up happening is that you don't finish your automation project, or it doesn't deliver on the promises that you may have made to your bosses when you said, hey, we're going to do this automation project. The last thing is, I think, very important in enterprise organizations, and that there's often a lot of resistance to automation. Normally, there will be a core group of people in the organization who feel that we must do this automation thing because it's quality of life in general for them. But every time they automate something, what ends up happening is that folks see their jobs being automated away. And if you aren't in tune with that, if you aren't considering that during your automation process, then you can be, you can experience a lot of resistance there, and you won't achieve the goals of your automation project. And so when we work with clients, we help them to solve this conundrum around automation. And so what we tell our clients is, don't boil the ocean. I'm sure you've heard this before, but it's very, very important from an automation perspective. You can't automate everything all at once. And if you try to do that, then your keep the lights on business gets pushed aside in favor of an automation project that may or may not show you benefits down the road. The next thing is you have to sync your processes up. Again, if you can't describe it on paper all the way through, it's very difficult to automate. So you have to go through your processes and make sure those things are cinched up. The next thing is start small. Again, keeping in line with don't boil the ocean and trying to introduce a massive amount of change, when you do select the thing that you want to automate first, it needs to be a very clear and concise unit. You shouldn't try to automate your entire pipeline, right? You want to automate a piece of your pipeline, and you want to start small and gradually move through to the bigger automation pieces. And the last point is that automation should enable, not necessarily replace. When you start to automate people's jobs away, and make no mistake, when we implement a lot of automation, you are automating someone's job away somewhere. We must remember that the system that we're automating needs to enable engineers, it needs to enable folks to do more, to do better. We should not automate just for the sake of automating so that we can eliminate 10 jobs, right? And so we try to work with clients a lot around ensuring that there's proper training programs set up, and that the folks whose job might be being automated away are very involved in the process so that they can own the process and improve the process later on down the road. So we've solved our automation conundrum in principle. So what does that look like in practice when you want to start an automation project in your organization? Shadowsoft has come to realize that over the years and over these engagements that we've been doing is that there's really three core principles to remember when you're starting a new automation project. The first is to envision your end state. This falls into alignment with your ability to describe the thing that you want to automate, but also your ability to say, what is the benefit that I'm hoping to see, right? The next thing is to measure what matters. Measuring what matters is incredibly important. If you're not keeping metrics about what you're doing, then you're not going to know if you improved. The third step is to select the right tools. And really, I should have put right in quotations here, but what that means is selecting tools that do the job that you need to do. So let's dig into these 3 points just a little bit and try to expand on what these things mean. So point number one, envisioning your end state. So when you start an automation project, you should say, what am I hoping to get out of this? What's the change in my current process that I'm hoping to see? And what is the kind of the ultimate goal? Maybe that goal is strictly to reduce toil. But that goal could also be to free up somebody's time in order to allow them to pursue another project. The next thing you should look at is, what's your actual timeline? Is this something that you need to get done now? Is this something you need to get done later, right? So when you look at timeline, you're also going to consider things like the priority. So priority for you is often very different than the priority for the business. So many of these quality of life things that we tend to do inside of an automation, inside of the kind of the automation paradigm is their quality of life for the engineers. They make it easier for the admins to configure and manage system state. They make it easier for the developers to check in and deploy code. But if you can't articulate that to the business, then a lot of times you get things pushed down the priority level. And the last thing is, like, once you've figured out timeline and once the business says that this is important, you really have to put some thought around the resourcing you're going to need. How much is this going to cost, both in the terms of actual dollars, but also in people's time and where the opportunity cost is there? How many different engineers are you going to tie up in this particular effort so that they have a working knowledge of how the system is built and can maintain it going forward? So this is the first point, is that you should always envision your end state and have a very clear understanding of what the project is going to entail and what the goal is that you're going to reach. The second point here is about measuring what matters. And we are very passionate about metrics at Shadowsoft. It's extremely important for you to not only baseline your existing environment, but to always keep metrics and keep them updated. But most importantly, keep them visible. Metrics are no good to your organization if you're the only one who can see those metrics. Creating a common purpose and shared kind of vision for your infrastructure and your processes is very, very important in your organization to help everybody keep trying to improve and driving towards a common goal. So what are some metrics that you should be looking at? We like to look at things like build time. How long does it take to build my code or my VMware template or my EC2 AMI? How long does the artifact actually take to build? The next point is a successful build. So maybe my artifact builds really quickly, but it fails half the time because of some unknown dependency, right? So successful builds are very, very important to keep track of, in addition to the build time. The next piece of this is deploy time. So how long does it actually take to deploy the artifact? This can include the spin up of infrastructure. You can break that out if you want to. So you can say, well, the code deployment takes this long, but the infrastructure deployment takes, an extra 8 hours. Therefore, the total deployment time looks like this. And it's very important to consider that for failure recovery scenarios. Also in the deploy time, oddly enough, we look for successful deployments. I'm sure many of you have experienced situations where you deploy code and the environment's messed up, or you try to deploy infrastructure and you've run out of VMware resources like that, and you can't actually get a deploy to go. And so even if you're increasing, as you increase the number of deployments that you do by shrinking your batch size down, right, the number of successful deployments becomes really, really important. Another thing that most developers don't like to think about, but operations people tend to, is how many open issues are opened as a cause of the deployment. So how many infrastructure tickets get open? How many bugs get open in the code? How many customer problems are reported as part of the deployment, right? These are all very important things to capture, because what they do is they show you the quality of your release pipeline and the quality of your release process. The last point is also really important, and a lot of folks kind of take it for granted, and that is the recovery failure time. So this is your roll forward time, because we're DevOps and we don't roll back, we always roll forward. The recovery failure time is the time it takes for you to redeploy a working version of your application. So if the infrastructure in your new deployment is screwed up, right, this can be the time it takes to rebuild all your infrastructure. It can also be the time it takes to simply flip back to your blue environment if you're doing a blue-green deploy, for instance. This number is important because it needs to stay low relevant to the other changes that you're making in your pipeline. So if you're making a bunch of changes in your pipeline and those changes make it so that your recovery failure time increases as opposed to stays the same or decreases, then we're making bad decisions about our pipeline. So metrics are very important, and you should always measure what matters. The last piece of this little framework is around selecting the right tools. And again, I said right in quotation because right has different meanings for different groups. At Shadowsoft, when we say the right tool, we have a small framework that we use to select a tool for an automation project. The first is, does the tool do what you need it to do? It doesn't matter how cool the tool is or how cheap the tool is or how many likes it got on Instagram. If it doesn't do the thing you need it to do, and if it doesn't do that thing very well, then you're not going to be satisfied with the tool. So does it do what you need it to do? The next thing is, does it integrate with your existing tool set? If the adoption of a tool causes you to have to adopt 10 other tools, then what that does is it just creates a lot of cost and technical debt inside of your organization. And any benefit that you may have realized from selecting this tool quickly becomes overshadowed by the amount of effort it takes to completely change other processes around the tool. So you can think, old Pivotal Cloud Foundry, for instance, before the Kubernetes thing, you had to completely rework the way that your development processes happened in order to be able to use the platform. So does it integrate with your existing tool set? The next thing is ease of adoption, and ease of adoption gets thrown around a lot. Some people say, well, it's easy to adopt if it's easy to read or if it has a good DSL or something like that. But ease of adoption actually has little to do with the software and much more to do with your organization's ability to assimilate that software. So there's three key points when we talk about ease of adoption. The first is in-house technical ability. Do you have people that know the tool or know the language the tool is written in? For instance, if you're considering becoming an Ansible shop, Ansible's modules are written in Python underneath the hood, and it would be beneficial to you to have someone who already knows Python. If you already have a team of people who knows Python, it's much easier to adopt and customize a tool like Ansible as opposed to a tool like Chef that's written in Ruby. The next thing you should look at is it already in use in your organization? Large organizations tend to have a lot of silos, even if they're trying to do the DevOps thing. And in each of these silos, what we tend to see is that an organization will be using a product. So for instance, the parent company might be using Ansible. And as a new subsidiary, you have to choose an automation tool because they'll tell you, everybody uses a configuration management tool in this organization. And so you might go down the road of trying to have a bake-off between Chef and Puppet and Ansible, when really if you had just asked, you would find that there is a wealth of Ansible resources inside your organization. So it's very important to look at this and say, is it already in use in my organization? The last point is that, is the product easy to hire or train for? So if you are trying to adopt a tool that is very cutting edge, and the folks that know that tool are very expensive, then, and you're not willing to be kind of a fast follower and dump $20 million into going Kubernetes 2 years ago, then you have to take a step back and go, this may be the future, but my organization is not ready for this type of thing. And so I need to either look at a different tool, or I need to look at an intermediary step, or I need to work on my hiring plan around this tool. So ease of adoption really means these 3 points, and you should think about this from the business perspective. From the development perspective, we look at things and we go, oh yeah, I know Ruby, or this tool looks cool. It's got a thriving community online. There's a lot of places I can go for help. And for developers, that's great, but for the business, you need to think bigger picture. The last point is that, and I'm going to ask all the salespeople to put their earmuffs on if there's any salespeople in earshot of me right now. You have to ask yourself this question: how easy is it to unwind from? So Jeff Bezos is pretty famous for talking about the way that he does business at Amazon. And the one thing he talks about is the difference between type 1 and type 2 decisions, that we should try to increase our propensity for these decisions that are easy to come back from. And if you look at a decision and go, if I make this decision, 6 months down the road, I don't like it, I can easily back out of this decision and do something else. And so when you look at a tool, you should look and say, is this going to tie up my entire organization? Is this going to cause me so much pain from a implementation perspective that it makes it so that I can't get away from it later on? Now, this is different than vendor lock-in. So the idea of vendor lock-in is, I'm using AWS, for instance, and I'm completely locked in. I use all AWS things. And that's not actually true with a lot of vendors, because a lot of vendors actually make it very easy for you to unwind from their particular tool sets. So these are when we say we need to select the right tools, these are the things we talk about with our clients, right? Does it do what you need it to do? Does it integrate with your existing tool set? Is it easy for your organization to adopt? And is it easy for you to unwind from in case we don't like the decision 6 months down the road? Or maybe we discover that there's some bug or there's some particular edge case that's really important to you, but it's maybe not important to the community whose tool that you're using. So very important to select the right tools. Okay, so I've gone through a lot of information here, and now what we're going to talk about is we're going to actually get into an engagement that we did very recently, and we're going to use this framework and these ideas to show you how we were able to create an automated build pipeline and how that process worked. So the first thing to understand is that the problem of having to automate your build pipeline is a very common problem. Organizations struggle with this all the time, even really advanced organizations, because a lot of organizations, and in particular this client, build things from hand. They built their VMware templates completely from hand, and there was one guy who knew the VMware stuff, and this person was responsible for it, and we didn't really have a lot of documentation. And so what happens is you have to build your image from hand, and when you do that, you have to grab an operating system. You have to install the required packages on your operating system. You might have to install your application. You might have to customize that particular image for what data center it might be able to go in. And then what you have to go do is you have to do this X more times for every single one of your apps. And then you have to go back and redo it, because most of the time we don't include security in this process. and so our images end up being insecure. So this is a problem that a lot of clients have, and this is something that we have gotten very good at solving for. So what does this look like? So let's take our framework that we talked about, the 3 points that we talked about before, and I want to walk you through kind of how this worked out for the client. So the first thing was to envision their end state. Their end state was really focused around freeing up engineers' time from toil. And in particular, this one engineer who was their main VMware talent was constantly getting pulled into building these images because he had all of this contextual knowledge around it. This was very, very high priority for this client, but they were very low on resources, hence the reason they reached out to us. And so ultimately what they wanted to do was automate the toil, right? This is the Google word toil, but basically it means things that you're doing constantly that you should automate because they're low impact to the organization. So the next thing is we said, okay, we need some metrics here. We have to build a baseline. So we took some baseline metrics. We had about a 7-hour build time for these images. We had a lot of build errors. As a matter of fact, the build errors for the images was so high that we didn't bother tracking them. We just said there was a lot. And you know, these things happened quite frequently. Build errors were mostly related to things in the environment, or when we would try to deploy the application code, we didn't have the right version of something, right? Or it had been tested with a different version of that thing. It took about 2 to 3 days to deploy the entire stack. So this was the process of building the images, using those images to using those templates to launch instances in VMware and getting Ansible to actually configure the instance for the data center and deploy the code. So 2 to 3 days seems like a very long time, and it was. And the other thing that we discovered is we had a lot of deployment failures. So about 25% of our deploys were just failing. And this was a result mostly of environment errors in the build process for the images. And so by the time we got to deploy the code to these instances, they weren't really ready for that. Okay, so we went through these two things first, and then we said, okay, let's pick the right tools now. We're gonna make some tooling decisions. So on the left, you can see these are the core pieces of an orchestration pipeline for building images and getting these images ready to have application code deployed to them. So the first one is image creation. Image creation often, again, is done by hand. So how do we make this more programmatic? So Packer is a tool from HashiCorp that allows you to programmatically design the way that an image is built and configured. You can produce VMware templates with it. You can produce AMIs with it. You can produce VMDKs with it. There's a lot of options that you can do with Packer. Packer also allows you to call out to and integrate with other tools. So from a configuration management perspective, right, from the actual installation and configuration of the node, we looked to Ansible. This decision was made because the organization, the parent organization, actually had Ansible in-house. And the users of this particular pipeline were Python users. So it made sense for them to select a tool like Ansible that they already had some knowledge in, they already had some best practices for their organization from a security standpoint around, and that they could customize if they needed to. The next thing is provisioning, and provisioning is sometimes confused with configuration management. So yes, Ansible can call out to VMware on AWS and spin up instances. Should you do that with Ansible? Probably not. Just because you can doesn't mean you necessarily should. Again, when we're choosing tools, we want to choose tools that are purpose designed for that particular use case. And in this case, HashiCorp makes a product called Terraform. A lot of you probably are using Terraform, the open source bits in your organization currently. Terraform allows you to, much in the same way that Packer, have a programmatic way to talk about what your infrastructure looks like from a provisioning perspective. And it has the ability to integrate with several other tools. So how do we tie all this together? Well, so most of you are familiar with Jenkins. Jenkins is a pipeline orchestration tool. It's a cron server on steroids for some folks, but it allows you to centrally control the execution and flow of your build process. The next piece of this is testing, and testing is often really overlooked, especially on the infrastructure side of the house. Oftentimes, developers will write some tests for their code, but operations folks and DevOps folks forget to write tests for their code, right, their infrastructure code. So there's a tool called Inspect from Chef. Inspect is a framework for infrastructure and application testing. In this particular case, we were able to write Inspect tests to test all manners of the process as far as the image build and deployment was concerned. We used the outputs of the Inspect tests to inform our Jenkins orchestration, and that's how we were able to automatically control these build pipelines. So we've gone through our little framework. We've selected some tools. We have our end state. We know our baseline metrics. So what did this look like when we actually took a first pass at it? So what you're looking at here was our first implementation, our first iteration of this pipeline. So using Jenkins as our orchestrator, the client had Artifactory on-prem already for our binary storage. We decided we were going to leverage Packer to create and use a base Windows image, and we were going to use that to create what we were going to call our base vSphere template. For each of the base templates, we looked at the client's application stack and logically separated it based on the teams that they had. So they had a web team, a database team, and an API team that all kind of came together to produce what this application looked like. So from our base vSphere template, we were able to create images for templates for the web, database, and API base levels. So the web base level only had the things on it that web servers needed, and the database only had things on it that the database needed, and they all had the core things like the monitoring tools and that sort of thing that all of the templates needed. So this actually worked out really well. So we were able to automate some things, but when we went back and checked on the metrics, we discovered some interesting things. The first set was the build time was still quite high. The build time was still taking about 5 hours. So we were down from 7, but only marginally down. And that was very odd to us, right? Because we had automated this entire pipeline, and so we thought, hey, our job might be done. But because we think metrics are so important, we were able to look back and go, wait a minute, something's not quite right. So errors were down in our pipeline, which is really good. So the errors in the build process were much lower, right? Where they were so common before we didn't even track them, and now they were so few that they are generally isolated to an edge case. So for instance, somebody updated a version of some package in Python and didn't tell everybody kind of thing, right? So it was an edge case type of thing. And so as a result, the build consistency or the successful builds, right, greatly increased. Another thing that we found is that our deployment time, our overall stack deployment time, was only marginally faster than doing it manually. And part of this had to do with the fact that we had not yet automated the actual deployment of the application. We are going to talk about that just a little bit later. But even having this process automated, we noticed that build time is still high. Our deploy time is only marginally faster because we're only saving an hour or so in the build process. So this was another thing that we thought was really interesting that we needed to go back and look at again. The last thing is that the deployment failures were greatly improved. We were at 1 in 4 deployment failures before, and they were almost always an environment error where we had not configured the environment correctly for the version of the application that needed to be deployed. And so we dropped that down to 1 in 10. So that was an incredible increase in the consistency of the build and our consistency of our deployment. And what we discovered is that now we're dealing with application level problems and not environment level problems of our system. So we had 4 things that we were looking at before, and we realized that 2 of them were good, but 2 of them were just not very good, and we needed to go back and look at why. And so when you look to improve your process, one of the things that you have to do is you have to communicate. You have to go to your developers, and you have to go to your release team, and you have to go to the business, and you have to say, what are the actual use cases for this automation thing? We thought we understood, but clearly you're not using it in a way that makes it more efficient, and we thought it would be more efficient. So we had to go ask about some use cases, and what we found is there were a bunch of use cases that needed to trigger partial builds that were instead triggering complete deploys, and thus creating this long deploy cycle. And so when you look at things like rebuilds, so for instance, if a security patch comes along, you should have to rebuild all of your templates. But if a patch for just the web server comes along, you shouldn't rebuild everything, right? Your pipeline should have the ability to only rebuild the web portion with the thing that only the web tier needs. And the same thing can be said around hot fixes for code and things in production when you're doing your deployments. And so when we started to look at these use cases, we realized that there was an opportunity to greatly decrease our deployment time and our build time for these particular images. And so what we were able to do is go down to 30 minutes. We were able to do certain ones in 30 minutes, certain ones in about an hour. So this is a great improvement over where we were at. So how did we accomplish this? So if you'll notice here, we've actually added a secondary layer of VMware templates. So what we discovered when we were looking at use cases is not only was there a requirement to rebuild just the web tier or just the API tier, we discovered that in the web tier, in the API tier, in the database tier, that there were certain components of that template that didn't change very often, and certain components that did change very often. So when you isolate the things that don't change very often into its own step, that allows you to essentially use that as a sub-base image. And what this allowed us to do is to rapidly rebuild the actual VMware templates, because the changes that were being done were very small as opposed to rebuilding the entire template. So we worked with the team to really define which items were things that didn't change very often and which items were things that did change very often. And that's where we drew this extra layer of separation. And just that particular change allowed us to greatly reduce the most common use case build time. Additionally, we created Jenkins jobs to allow us to insert ourselves anywhere inside of this overall pipeline. So again, if you're going to rebuild your base image, you're looking at it rebuilds everything. But if I only rebuild the web base, then I only need to rebuild our secondary web base template. And so giving the operations team the ability to step into this workflow in the places that they needed to account for the use cases is another way that we were able to greatly reduce the practical deployment time of this application stack. So this helped with the build of these templated images, but we needed to incorporate the final piece of this CI/CD process, which was actual deployment of the artifact. So if you look at this, so if you can imagine that the top graph bleeds into this graph, I want to talk briefly about how this process works, and there's two really important things that I want to point out here. The first is that you still, a vSphere template is like a sysprepped Windows image. You have an image that's fully built and has all these tools on it, but it doesn't have a host name or an IP address, or it doesn't know what its NTP server should be, because it doesn't know where it's going to get deployed in your environment. And so leveraging a tool like Terraform allows us to not only control this provisioning process, but also control all of the network provisioning and all of the security group provisioning and any of the kind of infrastructure level configuration items that we want to use. And because it integrates so well with products like with Ansible, what we were able to do is leverage Terraform to deploy the vSphere templates And depending on where that template was getting deployed, Ansible was able to contextually configure that image for that particular environment and for that particular data center. In this case, the client was leveraging VMware, but they were actually leveraging VMware on top of AWS as the first part of their cloud journey. So they had their infrastructure as a service and VMware deployed on top of it. So to the teams, it was very transparent. They didn't have to worry about it. It was not transparent. It was abstracted away from them. But because of Ansible and Terraform's ability to interact not only with VMware, but also with the AWS APIs, we're able to build a very concise and very tight deployment pipeline. So what we did is, as the images would get spun up, Ansible would configure the images not only for the data center, but it would also then deploy the application. So the application was being built again with Jenkins, and that build process was putting an artifact into Artifactory. And so we're able to pull that artifact out and deploy it onto the configured node in AWS. And we started with their dev environment because when you first dip your toes in the automation waters, you're not sure if there's an automation shark swimming down there that might eat you. And so a lot of organizations still want the ability to have a human operator to inspect the process. And this is not a bad idea. Developers have code reviews where a real person looks at their code all the time. So why, as operators, should we not consider that a best practice from a development perspective to maybe review how things are going? This may be simply looking at the output of inspect. In this particular case, if any particular part of this deployment failed their inspect checks, the whole deployment would fail. So the human operator in this case was simply looking at the outputs of some inspect checks, but also running a couple of smoke tests that they knew were things that they needed to check in their web app, but were a little difficult to automate because it required contextual knowledge about where the thing was deployed and how a user might click on something more times than they should, right? So we created this pause here to allow for a human to say, okay, now I want this to go to production. So when we look back, right, because again, we're keeping track of metrics, we're measuring what matters, we started with this problem of slow, manual, error-prone builds and deployments. And these builds and deployments took quite a good amount of time. So our build time was quite high, but we've managed to get that down to less than an hour from 7 hours before. Our build errors, we managed to take those from being very frequent and common down to only isolated to edge cases around the application stack. Our deployment time went from 1 to 3 days to less than a day to deploy the entire application stack, and that's a complete rebuild of all of the infrastructure and the deployment. And we looked at our deployment failures, which were quite high, and we're able to reduce those down to a level that made it so that we could deploy much, much more frequently and isolate the deployment errors more towards the application as opposed to the infrastructure stack. So I know this has kind of been a lot, and I've gone through a lot of high-level stuff, but I really want to illustrate to everybody how automation, when done right in your environment, when taken in an iterative process, follow the framework that Shadowsoft has put in place, you can be successful. And you can prove that you're successful by gathering metrics around your build and deployment process. So thank you all for listening to me. We're going to have some time for questions, and I'm going to hand it back over to Ross for just a moment.
Thank you, John Ray. We will get to Q&A in a second, so if you have questions, type them into the chat pane right now. I'll give you a couple of minutes, and while we wait, I do want to let you know about our infrastructure automation workshop. If what you learned today was interesting and you want to kind of take the next step with Shadowsoft, we would love to host a workshop with you. Inside this workshop, you'll learn how leading organizations are automating with infrastructure as code and CI/CD and DevOps best practices. Register at shadow-soft.com/automation, and we will follow up to schedule that workshop with you.